Alright, we're going to finish up section 4.2 looking at factored form. We haven't looked at that, although we kind of have because this is just what it looks like when we factor it. Two sets of parentheses, maybe a GCF of the A there. Other than that, it's the same. But notice again, these are minus. So our x-intercepts are P and Q, not negative P, not negative Q. So our x-intercepts are opposites, just like our x-coordinate of our vertex was opposite. If we look at the vertex form, f of x equals a times x minus h squared plus k, we can get our vertex from vertex form. Shocking, I know. But our vertex is h comma k, again, opposite of what's in here. Then we have standard form, f of x equals ax squared plus bx plus c. We can get the y-intercept from this form, and that is just our last term, our constant. So if we could change these, or if we could get all, or one equation in all three of these forms, we could figure out the vertex, the zeros, and the y-intercept, and we'd be able to have a good graph. Something else that, I don't know, I find it neat, this A is the same as this A is the same as this A. So if we were to put them in different forms, that number stays the same, which is kind of cool. Alright, let's see how we can deal with this, or specifically graph from factored form. Alright, so we got this example drawn out for us. Use factor form to graph a quadratic function. So we get x squared minus 2x minus 8 equals f of x. First, set it equal to 0. Check. Second factor, so they kind of skipped a little bit. So we want two numbers to multiply to negative 8 and add up to negative 2. That'd be negative 4 and 2. And because the coefficient of x squared is 1, we can go right to x minus 4, x plus 2, and that's what we have here. So now we set each equation equal to 0. So x plus 2 equals 0, or x minus 4 equals 0. In that first one, you're just subtracting 2 from both sides, so you get x equals negative 2. You don't need to write that minus 2 if you understand where it's coming from. And similarly, x minus 4 equals 0. You add 4 to both sides, x equals 4. So we have our two zeros. To find our vertex, you're going to find the average, and that's all it is, the average of the x-intercepts. So to find the average of two things, you add them up, divide by 2. And that's what we did here. 4 plus negative 2 is 2. 2 divided by 2 is the 1. That's our x-coordinate. And just like before, we plug it in. Plot the vertex and the x-intercepts, connect the dots. Alright, we'll go a little bit slower on the actual examples, of course. Graph f of x equals 1/5, x minus 3, x plus 7. So first, our zeros, well actually I guess, let's write down our steps again. So first, set it equal to 0. So 0 equals 1/5 times x minus 3 times x plus 7. Next, we would factor. It's already done. Kind of cool. Then we set the factors equal to 0. So 1/5 equals 0. X minus 3 equals 0. And x plus 7 equals 0. So if we look at all of these, well, 1/5 equals 0. That doesn't make any sense. 1/5 is not 0. X minus 3 equals 0. We add 3 to both sides. We get x equals positive 3. Or another way to think about it, what minus 3 gives us 0? Well, it's got to be 3. Likewise, x plus 7 equals 0. We'd subtract 7, so x equals negative 7. So those are our two zeros. We have them at 3, 0, and negative 7, 0. Those are our zeros. So we can graph those. There's 3, 0, negative 7, 0. Now we need one more point to graph, and the point we're going to get is the vertex, so we can really see what's going on in this diagram. So to find our, let's see, solve for x, that gives us our zeros. Then find the vertex x coordinate. Of course, that's h, which is our two zeros added up divided by 2. So 3 plus -7 over 2. That would be -4 over 2. Grand total of -2. Now we need to find the vertex y. Of course, that's k. And you just put h into the function. So in this case, we'll substitute in -2. We got 1 over 5 times -2 minus 3 and -2 plus 7. So now we just do our order of operations. Parentheses first. So -2 minus 3 is a -5. -2 plus 7 is a +5. Exponents, none. Multiplication, yep. 1/5 of -5 is -1. -1 times 5 is a -5. So that is our k. So we have our vertex. Vertex is -2, -5. So we found the vertex. Then we plot the points. Just put them on our graph and then connect them to make a parabola. We want our parabola to be, looks like a U, more rounded than pointed, and ideally go through these 3 points. So -2, -5. So if you have those 3 points correctly, no matter what kind of parabola you draw, I'll be okay. It's not necessarily super easy to draw good parabolas. That's not great, but it works. So again, these are our steps. Steps 1 through 4 is what we did in the beginning of 4.2. And then 5, 6, 7, 8 is what we are learning today. All right, let's try another one. Got some leftovers here. Let's erase that. Graph f of x equals x squared minus 8x plus 15. I'm not going to write out the steps again, but obviously you can go back, write them down, and as we go through this, check them off. But our first step is to set it equal to 0. So 0 equals x squared minus 8x plus 15. All right, it's equal to 0. So now we need to factor. We want two numbers to multiply to 15 and add up to -8. Now remember, when we do this top number, it's actually a times c. Well, that's 1 times 15, which of course is just 15. And then our b term is down there. Of course, this is our product, and this is our sum. So what two numbers multiply to 5 and add up to -8? Well, that would be -5 and -3. And because our coefficient of x squared is 1, we can skip right to this part. So -5 and -3, -5, -3, and x is in the front. No GCF. So now, I believe it's step 4, we set each factor, equal to 0. So x minus 5 equals 0, and x minus 3 equals 0. Again, intuitively, it should be obvious, but you can always do the separate operations. It's just a one-step equation. But x equals 5, x equals 3. So we have zeros of 5, 0, and 3, 0. So we can plot those. 5, 0, 3, 0. Now, just looking at that, I'm guessing a good number of us, if not all of us, could figure out the x-coordinate of our vertex. But let's check it out. So remember, to get our vertex x, we take the average of the zeros. So our p plus q divided by 2 would be 5 plus 3 divided by 2. That's 8 divided by 2, and then 4. Hopefully that was obvious. 4 is directly in the middle of 3 and 5. So we have our x-coordinate So we're halfway there. Now we need to find our y, and we just substitute that back in. So f of 4, so that would be 4 squared minus 8 times 4 plus 15. So parentheses first, nothing inside parentheses to do. Exponents, yep, we got one. Not going to do anything else on this line. Now we can do our multiplication and division, but of course there isn't any. Then we can do our adding and subtracting. 16 and 15 are 31. 31 and negative 31 gives us a grand total of negative 1. So our vertex is at 4, negative 1. So we plot that, we connect them. See what I mean? As long as it is near that point, and I know that's the 0, it's fine. Does it look good? No, it looks horrible. But I know that you found the right stuff. Alright, we got another one here. Graph negative 2x squared plus 8x plus 10. So we're just going to go through those same exact steps. First, set it equal to 0. Excuse me. Set it equal to 0, now we factor it. First thing we have to do is take out a GCF, because there is one. 2 goes into 2, 8, and 10. Now we're going to take out a negative 2, because whenever our x squared term is negative, and we're factoring, things kind of get weird. So I think it's easier if we just take out a negative 2 with that. So negative 2 divided by negative 2 is 1. Don't have to write 1. We have our x squared left. 8 divided by negative 2 is a negative 4. Still have the x. And 10 divided by negative 2 is a minus 5. So that's what we have. Now I'm going to write this just like we did several units ago. We just draw where we're going to put our GCF so we don't forget it. Alright, diamond problem time. Coefficient of x squared is 1, so 1 times negative 5 is a negative 5. Negative 4 is our b term, our sum. What two numbers work for negative 5 and negative 4? Well, that would be negative 5 and positive 1. And since our coefficient of the x squared is 1, forget about the 2, then we can skip right to our factoring part. So x minus 5 and x plus 1. Alright, so we factored it. Now we set each factor equal to 0. Negative 2 equals 0. X minus 5 equals 0. And x plus 1 equals 0. Well, first one, negative 2 equals 0. No, it doesn't. Don't lie to me. X minus 5 equals 0, so x is 5. X plus 1 equals 0, so x equals negative 1. So we have zeros of negative 1, 0, and 5, 0. So we're going to plot those. Notice this graph is going by 2's, because we're going to get some bigger numbers. So negative 1, 0 is actually in between two grids, or two intersections. And 5, 0 is the same type of thing. It's 2.5 boxes. So those are our two zeros. Now we'll find our vertex. And if you remember, our h, or our vertex y, is p plus q, so it's negative 1 plus 5, divided by 2 is just the average. So that makes it, see, negative 1 plus 5 is 4, 4 divided by 2 is 2. So we know our vertex has an x-coordinate of 2. Of course, we could always find our h a different way as well, doing our negative b over 2a, which in this case is negative 8 over 2 times negative 2. That's negative 8 over negative 4, which is positive 2. That's exactly what we got. Both methods probably are just as easy as each other. Choose whichever formula you can remember. And either way we get our h or our x vertex, we got to plug in that x to our equation. Now, always remember your order of operations, because this is where I've seen mistakes. Parentheses, nothing to do inside parentheses. So exponents, yeah, we can do something. So we leave the negative 2 alone. 2 squared is 4, of course. So you do not multiply the negative 2 and this positive 2. You square the 2 first. So parentheses, none. Exponents, did it. Multiplication, all right. So it's negative 8 plus 16 plus 10. So that gives us a grand total of 18. So our vertex is 218, so it's way up there, which is why our graph is done by 2's. So 2 is really just one box, and then up 18 is really 9 boxes. So it's very narrow. Then we try and connect it as rounded as we can. Kind of hard because it's so narrow. And try and get close to the dots. And we have our parabola. So that's graphing from factored form.